Those Space People, a podcast series of casual cosmic conversations with people working on exciting space projects. Today we have Venkat Atmanathan with us. He is currently a research scientist at Purdue University and recently completed his PhD in aerospace engineering. Welcome to the podcast, Venkat.
Thank you.
I see that you have a bachelor in aeronautical engineering and then a master in mechanical engineering.
Yeah.
That was really interesting to me the first time I saw your profile because degrees often get progressively specialized.
Yeah.
But what's the story there?
When I got so I actually got an admit into Purdue in the aeronautical department. And the lab that I was working for was the propulsion lab, which is 50% funded by the aero department and 50% funded by the ME department. The professor I was working with was actually the graduate chair of the ME department. So he was saying that it'll be easier for him to actually get me all the administrative tasks done easier if I was in the ME department. So it didn't make any difference whether I graduated from the aero or the ME because the lab was the one that actually mattered. So I volunteered to switch to the ME department. And then for my PhD, I decided to go back to the aero department because it was easier personally for me there with respect to qualifying exams and then so the domain specific exams that you take to qualify to do your PhD. Those were all easier for me if I had been in the aero department as opposed to the ME department. So that's why I switched back to the aero department for a PhD. So I was admitted into the aero department, but then I had to move out to the ME and then come back to aero for my PhD.
I think it's really nice to have this kind of customizability in your courses and at the university. So that's really nice. Can we talk about your current research? Because you're currently a research scientist, you're leading a team in the aero department and also PhD research.
Sure. I'll go chronologically. So what I did for my master's, then to my PhD. So for my master's program, I actually worked on a gas turbine combustor, and it was sponsored by an engine OEM. They wanted to study auto ignition of diesel fuel in gas turbine engine environments. So I was funded by the engine OEM to actually get them critical data points where at high pressure and high flow rates, which are very close to what you would get at the exhaust of a compressor. Those conditions where when you're actually trying to study auto ignition phenomena, the reason you do that is because the exhaust of the compressor is actually at very high pressures and temperatures. So to give some numbers, it's close to 30, 35 atmospheres, and then the temperatures are on the order of 500 Celsius. So in that high temperature and heated environment, when you throw some fuel in, you can spontaneously combust the fuel instead of actually burning it in the combustor, which is what it's designed to burn. So trying to understand what those limits are was my master's research. And when I got into Purdue, I didn't have any funding. So thankfully, the timing all worked out for me to actually get the sponsored project. So at the end of the first semester, I actually started off working on this project. It lasted for about 2 years. We collected some good information for the engine OEMs. They were able to design their combustors and their compressors appropriately. At least that's what I'd like to believe, because we don't know what they use the results for. And lucky enough for me, when I started with my master's program, I was actually under the tutelage of the managing director of the lab. His name was Scott Meyer. Scott is an amazing engineer. He taught me everything that I know when it comes to rocket plumbing and getting engineering systems up and going for rocket and gas turbine combustion applications. So I was directly under his tutelage. He was the lead of the lab. He was in charge of the entire lab safety, as well as training new students on how do you put propulsion systems together. So that way I was very lucky to directly work under him. And so that's what kind of gave me a little bit of independent skill to, come up with any combustion or propulsion systems that I desired to build. That happened for about 2 years. And then the project had come to an end and there was no more funding left over in that particular field. I was also looking around for a new professor because I wanted to go back to the aero department as much as I can. And then I met my PhD advisor, Professor Barry Meyer, with whom I am a research scientist now. So he was a laser diagnostician, but he likes to use lasers in combustion environments at high pressure. And he was a new professor. He had a lot of startup funds for him to use in the university to build. The timing so happened that he wanted me to join the group because I had high pressure combustion experience. And so he said, why didn't you join the group? And I took up that offer because it was an experience to build a brand new lab. So that's what my entire first year and a half in Zucro was in my PhD. So the first year and a half, I basically took in charge of a lab which had just four walls and some high pressure plumbing into the lab, but nothing plumbed into any experiments. The whole lab was empty. And so yeah, we basically started spending all this startup money to build all this like high pressure fluid systems, and like we had all this amazing equipment. And then we started putting together different combustion experiments on which we do our high speed laser diagnostics. So that's what happened until my PhD. And then somewhere halfway through my PhD, we decided to work on this high speed propulsion topic called rotating detonation engines, which 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 has like detonation waves traveling at on the order of about a kilometer, 1.5 kilometers per second. That's a very high speed flow. So we wanted to like improve our laser diagnostics to those speeds and understand how those combustion processes worked, because regular flames generally are on the order of few tens or few hundred meters per second. This is like going at like 2-3 orders of magnitude faster. So you want to understand those dynamics. So we took our old laser diagnostic techniques, try to improve it to understand the combustion processes in these high speed flows, which is what everybody wants to do these days because you have supersonic and hypersonic flows, which is of interest in the order of the day. So that's what my PhD was. I helped develop laser diagnostics for those flows. But in the process, I also got to build all the propulsion systems that is associated to run this system and also design the system itself with a bunch of my colleagues. And so I finished my PhD, and then my boss was like, I would like to have somebody as a staff on staff to like help with the safety and the day-to-day operations of the lab. And so that's when I decided to take up my research scientist position. And being in an academic lab, it's also easier to get access into some of the latest and greatest propulsion technology without having to face a lot of ITAR restrictions, I guess we're going to talk about at some point. So yeah,
Wow, I always love listening
that's
to.
a lot.
No, it's awesome because I love listening to people talk about, especially people working on launch vehicles, a lot of propulsion. Because as someone who's never worked on a launch vehicle and just on satellites, the coolest part of my workplace, for example, is the solder lab.
Mhm.
So we don't have such amazing stuff. So I always love listening to details like this. It's so cool.
Yeah, I just wanted to say one thing. So when I started off in the lab, I did not know what a wrench was.
Okay.
So in about a year and a half, I didn't know how to solder. I didn't know what a wrench was. I didn't know anything about like different sizes
Uh-huh.
of wrenches. I'm just saying wrench, but that's
Yeah.
just one thing. But that is so basic that like people around here, I was like, what's a wrench? I didn't know anything. So it was a steep learning curve, but I had great like help from the creme de la creme of, I think, teachers with Scott. So he taught, like he would go down to that level to teach something so basic, and would take the risk of hiring a student who has no idea what he's doing, and still keep going on with progress. So that's just wanted to say that, because if people sometimes feel intimidated, so it's easy.
Okay. No, it's not at all. I'm glad you said that because now I have more confidence that I can also, pivot and get into rocket propulsion because I do know what a wrench is, thanks to biking a lot around Berlin. So I want to ask you a little bit about the funding. But before that, you mentioned your professor was a laser
Diagnostician. Mhm.
diagnostician. Sorry,
That's okay.
a laser diagnostician. So what exactly is laser diagnostics?
Sure. So back in the day when we went to the moon, and like I'm talking about like 1960s, 50s, when Russia built all the moon rocket and everything, almost all the systems were analyzed in a very theoretical fashion. And then most of the data they collected was basically thermocouples and pressure transducers along the wall. So they would only look at what is happening at the wall profile and try to like design systems with whatever information they can get on the wall. But in reality, the combustion process is a lot more global and involved in terms of impacting the wall profile. So just because you read something on the wall doesn't mean it's actually very close to what's happening inside the combustor. So in order to understand those processes, from the 1960s through like the 80s and 90s onwards, there was a parallel group that was actually like developing lasers and trying to use lasers to understand how the combustion process works. So the way they were doing that is through this process called light matter interaction. So they would use a coherent light source like a laser, and they will try to image how the flame looks and try to get some information on the chemistry of the flame, and then try to analyze that over time to collect statistical data to say this is how the flame is operating. So laser diagnostics is, I guess, for combustion especially, is about I want to say conservatively about 50 years old, but the combustion analysis and all those tools were extended even beyond that, like maybe another 70, sorry, maybe 80 or 90 years old. So laser diagnostics helps provide more information than what you used to get back in the day. So that's why it's pretty important. And so we're laser diagnosticians, and we want to apply these laser diagnostic techniques into high-speed flows to analyze and understand the techniques. The the benefit of doing this is you can provide validation for model, like data for validation of your numerical model as well as your theoretical models. So this is experimental evidence.
Okay, okay. Wow. Super, super duper interesting. Can we talk about how projects in general are funded at Purdue or at similar labs in the US or even around? And what kind of timelines do they have? Because a fund probably has a timeline, and yeah, the different sources of funding.
If you start off at a university in the United States as a professor, assistant professor is what you usually start off as. The university will provide the professor a startup money, startup capital. I don't know if I can tell the exact number, but it's to the tune of somewhere between $500,000 to about $1 million. And that is provided to the professor when he starts in a department, a tenure track professor. That means that he's trying to get a tenure in the university. So the university takes its own money and its own resources and gives it to the professor when he or she starts at the university. Then the professor uses that funds to start buying a bunch of, as well as funding the student in their lab to basically put this equipment together and start making some preliminary measurements or some preliminary data collection. So this is coming from an experimental standpoint. I guess for theoretical professors, they will buy things like computational tools and computers and other like resources, or even human capital for getting a good senior member into the group so that they can start producing some theoretical results. So for experimentalists, it's much easier because they buy equipment. So they do that, and then with that startup capital, they can also fund graduate students and postdocs and other kind of human capital as well. So they fund that and they try to get a bunch of data out, a bunch of papers out. And usually the professors takes about a year or two or maybe even three sometimes to gather some amount of good data that they can present to other funding resources. Now the other funding resources can be divided into two. One's the government, the other one's the private industry, right? So the government can support a more fundamental research which might not give you a result that can earn profit or not, just to see how science works. That kind of research is funded by the government primarily. Then the private industry, on the other hand, funds for you to get results specific to their problem. So they have a problem and they can get some results specific to their problem. So they also fund to like similar dollar amount, if you will. And so that's how basically the professor starts to get funding. And as he or she starts to get funding, they can start writing papers and then eventually gather enough citations to a point where about 5 to 6 years from the point they started, they are up for tenure. And then the tenure situation happens where like all the professors in the department actually look at your profile, look at all the work you've created, and then decide whether or not they should have you as a permanent faculty member in their school. Once you get tenure, which is the best part, I think, in a professor's life, once you get tenure, it's cruise control. They can't kick you out of the department that easy, but you also are, the job is secured. And then because you're a tenured professor, people will approach you for solving their problems because they think you have a certain level of expertise, which managed you to make the department accept for who you are. And that's it. That's where the professor enters from his early career phase to a mid career phase, about 5 to 10 years. There are times when the professor doesn't get tenure, or the department kind of preemptively tells them that you are probably not going to get tenure. Then the professor's best thing to do is actually leave the university and go to a different university and start off on a different tenure track position, or leave the university and go to the private industry and do their research in the private industry space, private or even government research labs. So that's kind of how the academic side of the world works. So I guess that's more than you asked for, but yeah.
That's very comprehensive. I really appreciate that. And speaking of human capital, who all are often involved in university projects? I'm assuming students and full-time researchers or.
There's basically administrative staff, you have research staff, and you have management staff. So the administrative staff helps you like move paperwork, submit proposals to the website, receive results from the proposal website, does all of that administrative work for you. That's a no-brainer, and that's usually funded by the department. The management staff, as well as the management or professional, is called an MP level, and that's what I am, or research staff. So the management staff or management or research staff are the ones that actually help with the day-to-day operations as well as the safety of like equipment and the students themselves. Safety is actually, sorry, this is again going on a different tangent, but we usually tell the students that they are responsible for their experiments, but then it is still our overall goal to make sure that we minimize those risks for all the students and keep the lab functioning good safe. So that's those kind of staff are actually funded by a professor or a couple of professors. So if I'm helping 2 or 3 professors, all 3 of them will pitch in a certain amount of money depending on the amount of hours I put for their group. And the same goes for the managing director of Zucro Labs, for example. He is actually funded a good chunk by the ME department, a good chunk by the ARO department, because they want to have a human capital that is actually in charge of the whole entirety of Zucro Labs. But also there are other projects that we try to involve Scott in, for example, where he gives his professional input on the design and in the operations of an experiment. When we do that, we pay him by the hour, depending on whatever his hourly rate is. He's a salaried person, but still funds go from a project to meet his salary requirements. And that's the same that goes for even professors actually teach, but then in the summer, professors don't get a salary. So all these projects will basically be paying, all the projects that the professor has is what is going to pay him or her during the summer months. So that's how it works. So that's how I guess funding is spread around.
You've given a really comprehensive perspective on how this whole aerospace research kind of works, the whole scene. So that's interesting. Let's talk about ITAR regulations, right? The famed ITAR regulations, which essentially make it difficult. I wouldn't say impossible, but make it difficult for non Americans, foreign citizens to work in the space sector, even the private companies. But are there ways to get around this, like getting some sort of a special waiver or a special visa? And how good does one have to be to get this sort of special treatment?
Yeah, so there are ways to get around the ITAR system. So one of the first things, especially in an academic lab, that you can do is request your funding agency to see if you can have an exception for a certain professional or a student to work on a project, because they are the ones that you have and they're probably good at what they do, and so you want them around. And so depending on the United States' relationship with that particular nation, as well as the way the particular funding organization feels about the individual's country and their origin, as well as the individual's accomplishment. So they'll actually look through your resume, the profile, and see if they're worth actually putting the paperwork to get him or her excluded from the ITAR requirements. That you can do. And so if you do that, then the person can actually work on that project. So that's something that I think my professor is trying to work towards getting me an approval for some of the projects, because the students need my help to a certain part of the propulsion system, for example. So they'll actually send an email out to the funding agency to see if they can make an exception to the rule. Now, the person that you contact at the funding agency might not have a say yes or no, but it'll actually go through their international trade and arms regulation office. So it'll go through that, and then eventually they'll make the decision call as to yes or no. There have been times where they've said yes. There have been times where they've completely outright rejected no.
So basically, just be the best in the world. Be in the top 5 in the entire world.
That's kind of chance. That's like trying to get your visa. Now that's one part. The other way in which, this is in an academic situation, even in academia, as well as if you want to go for work for a rocket company, the second method is to get an export control license. So it's one of the licenses that's pretty common. It's called a DSP-5 license. I think it's issued by the Bureau of Industry Standards or Industry Commerce. I'm not sure. But in any event, this DSP-5 license grants a person an ability to work on a certain project that is classified as ITAR. And once they get the DSP-5 license, it costs the company a certain amount of dollar, I think $5,000 or something like that. They are able to work on a certain aspect of a certain system. So I'm just going to probably focus on propulsion. So let's say you're working on a turbopump assembly, and let's say it's ITAR restricted, which usually turbopumps are. So if you get a DSP-5 license to work on a turbopump assembly, they will have a certain set of documents that they are able to release. You'll work on that, and you'll try to accomplish it goals for the company that you're working with. Now, let's say in case you have to interact with the combustor guy, because your turbopump is going to be mating with a combustor, there are chances that the combustor person has a lot of stuff that is actually ITAR restricted. And so if that is ITAR restricted, you want to access that because you need to optimize your engine. You now have to apply again for a DSP-5 license to actually access that component and those details because that's actually important to you now. So this is a pain for the organization, which is why SpaceX, Blue, none of these companies want to hire foreign nationals unless they are actually really up above in the pecking order. So that's one of the reasons why DSP-5 licenses are a huge pain. But there is a way. So just putting it out there. You would like to be, right? But they can always find human capital that is actually like fulfilling your roles and it's still a citizen. It's much easier to do that.
Now that you mentioned that they can always find another person, a citizen, who can fulfill the functions. So, do you think that there is enough human capital in the US? I don't know, for the next 10, 15 years. So, essentially, my question is, do you see the US government removing this entry barrier or lowering this entry barrier? I don't know, in the next 20 years?
I think one of the clubhouse meeting actually, one of the person called Mike Mealing, he's a VC at the Starbridge, yeah, VC funds. So he was, I think, saying that like the recent time that they relaxed was probably in like 2017. And at that point, I think the DSP-5 license is probably the latest and greatest where they could get access to a lot more stuff than what they used to get. But it's because of the fact that the technology is dual use. It's dual use, meaning it could be for civilian as well as military application. He was saying that he doesn't foresee a lot of the rules changing. And being in this industry for about 7 years, at least in an academic lab and interacting with a lot of people, it doesn't seem like it's going to go anywhere. And then to answer your question, whether they have enough capital or not, that I don't know if I have enough experience to answer that because I'm still freshly minted graduate student. So it's a question that I don't want to, I guess, try and answer even because I don't know all the numbers.
I guess time will answer that question. So, what happens to all the foreign students that pursue advanced aerospace degrees in the US? Do you see them continuing in the academy like you are? Or do they go back to their home countries or, I don't know, move out of the space sector altogether?
So I've seen all three happen. But predominantly, I've seen a lot of people actually branch out into fields that they are interested in, but they would be even more interested in is an opportunity available, but then that's ITAR restricted for them. A lot of the folks that I know that are foreign nationals, like from Spain, Belgium, etc., they all go work for a private company, and they're probably working on a project, like for example, gas turbine engines. They are actually uh, a technology that's not as restricted as rocket engines. So the engine OEMs like GE, Rolls-Royce, Pratt and Whitney, any one of these guys, they start to try and make exceptions to the rule to make sure that they can hire foreign nationals to work on these like subsystems like turbines, compressors, combustors. But a person that is interested in rocket combustors does not want to deal with air breathing combustors because their mindset is completely different because the engineering behind a rocket combustor is different from that of a gas turbine combustor. But even if they worked on a rocket combustor in their master's or their PhD, they might have to go and work on an air breathing combustor, which I'm not saying is not interesting. I'm just saying that it might not be the interest of the person that's actually working on. But so, yes, people go into sectors that are more admitting of them and their skills than just the rocket industry. This is just very close to aerospace industry because gas turbine engines are close to the aerospace industry. I've seen people go work for fire protection industry. I've seen people go work for environmental companies where they're trying to like study forest fires. Since you have a combustion background, I'm just talking from a combustion perspective. Since you have a combustion background, you can basically take that and apply your skill set into a different problem solving approach. I've seen people that did spray work, aerospace combustor spray work, take their skill set and actually go to HP and develop inkjet printers.
Oh, wow.
I've seen people that take the same spray work and actually go and work on cloud seeding, which is like geoengineering, which has nothing to do with combustors or aerospace. Now the question is, I can't speak for the other people whether they're having fun or not, but I just think that it would be a lot more fun if they were able to work in a rocket or a gas turbine combustor system as opposed to outside. So that's just me coming from a niche perspective. That's one thing. Then academia, yes, people do go to academia, but foreign nationals generally try to get a few years worth of postdoc experience, because the reason why you do a postdoc or a research staff position is so you build the contacts that you need, so that when you write a proposal, there is somebody in the funding agency that knows that you are doing good work and is willing to spend the money on you. Because if you don't bring in money, you're not going to get your tenureship, which means you're going to lose your position in a university. So that's why a lot of students typically try to do kind of a postdoc or a research staff position a few years before they wrap it up.
That's taking the whole space spin-offs to a completely new level.
Yeah.
Wow. That's so cool. Of course, yeah, it would have been amazing if they were able to contribute, especially after benefiting from all these really prestigious universities. But
Yeah, I think I remember your third question. Will they go back to their country? Now, that I think is a small fraction than it used to be, but the fraction is actually growing over and over year, I think, because of globalization. Every facility that you can get here in the US, you're able to get back in India. It's just you probably are going to pay $1 or two more, but then you should still be able to experience all the things you can that you get in the US. So I do see a good chunk of people actually trying to move back to India. And just in my close circle, at least 2, 3 people have moved back, and then 2, 3 people have intended to go back to their own country because it's much easier for them.
I think there's also a fourth option that people can go to a second country, or I don't know, third country. I also know somebody who did a master's, not a PhD, from the US. And is now, he's an Indian person, and he's now working with the German Aerospace Center, DLR, and working on really advanced projects. So I'm sure there's a lot of people like that as well. America's loss is Europe's gain.
America's loss is everybody's gain, because almost around the world there seems to be a lot more openness to working on this industry. Just from Zucro Labs, we lost 3 foreign nationals that we know are extremely good in combustion to a company in Germany, a space startup company in Germany.
Wow.
Without revealing names, a South African, a guy from I think Singapore, German himself, and an Indian. All 3 are like combustion experts and like rocket propulsion experts. All of these countries came to the US, spent about a decade working here on like really advanced propulsion concepts with liquid oxygen, gaseous oxygen, rockets, and they were doing combustion instability work, all of that stuff.
Wow.
And that entire human capital went to work for ITAR Aerospace. So there's like we make fun of it saying Purdue, Germany. So Zucro, Germany, or Purdue, Germany. It happens.
Yeah, I also tell people that it's incredibly easier to find opportunities in Europe or Germany, because here, for example, recently I was also switching jobs and I was applying to a couple of places across Europe, and every single company was asking me, their first question was can you start yesterday? So everybody, so there's a huge dearth of human capital across Europe. They're always super happy to accept anybody, essentially. Even they need not have space background, can also come from allied sectors. So yeah, a lot of opportunities here.
And in the same way, these people who went back and they immediately got a job in ITAR Aerospace and are working in like propulsion systems, the time it took for them to do that was like 9 months. But if I want to work on a rocket company, something in the US, apart from the 6 years that I spent, I'll have to spend another 4 or 5, 2 or 3 years at least as an Indian to try to get a green card before I can start working in that industry. And then if I just have a master's, I'll probably end up spending even longer because I'm going to get like an EB2. So it's just the time it takes between you graduating and then you getting a job in the industry that you are interested in is just phenomenally different between what it is in the US versus what it is outside. Yeah, it's amazing how everybody else benefits from folks who are trained and groomed by the United States to work on things that are very specialized. They're losing capital. The worst part is, like, even if you're studying in, for example, Canada, right? Let's say you're doing your master's and then you're doing your PhD, and let's say you take about 5 to 6 years. Every year you're in Canada actually counts as if you are a part of Canada. And so at the end of your PhD, or even before the end of your PhD, you can actually get your green card equivalent, a permanent residency or Canadian PR. Here, all the time you spent in your F1 visa is not counted at all. The only time it's counted is when you're on an H1B and you need to be like a certain few years here. So it's just, it's insane because somebody spent like about 6, 7 years of their life in the United States, but you're not considered as if you're a permanent resident. You're just still treated as a foreign national. And it's just, it takes a while. They have their own reservations about it being a foreign national, blah blah blah. But I think those walls and barriers are probably going to come down, especially because Ukraine, which used to be a part of USSR, is now exporting a lot of rocket technology. So building a rocket or flying a rocket is going to get easier and easier. What's going to get more difficult is the use case as well as the market, if you will. Yeah, it is what it is.
Yeah. It's also so baffling and surprising to me because in Germany, essentially, so you have something called a special work visa. It's called a blue card visa. It's not a German equivalent of a green card. It's still a visa. But if you earn above a specific amount, if your salary is above a threshold, and then you get the special visa, and that basically puts you on a fast track to getting permanent residency, which is green card in the US, right? And then citizenship. So within 21 months of holding this blue card visa, you can get a permanent residency if you have some decent German skills. Otherwise, it's 33 months.
Mhm.
And then I think you just need to spend 5 years in the country, 8 years in the country in total. That also includes the time you spent as a student to be eligible for the citizenship. And I think the new government even wants to bridge this gap. They want to make it, I don't know, 2 or 3 years, further shorten it. So yeah, I see a lot of people coming to Germany. And now in the last decade, where there's been a bloom of space companies in the US, Germany quite hadn't caught up. And now it's slowly catching up. And there's like ITAR Aerospace, there's a bunch of other companies, not only in Germany, but across Europe. So they're also gearing up and yeah, they need more human capital.
Yeah, I like history a lot, and so one of the things that I read about was how like the German engineers actually split, and one went to the US, the other one joined the Russian group, and so both of them are actually developing each other's space programs and like aiding and improving their propulsion technology. But the Russians actually had a much more superior engine technology that the United States didn't have. And when they learned about it after the USSR wall came down, they learned about the fact that the Russians actually had built like a closed cycle oxygen stage combustion, which the United States engineer thought that it's impossible to do because they tried it and then they like literally melted hardware like candle wax because hot it'll burn everything. Your engine metal will become fuel. So they abandoned it and they didn't do anything like that until they saw that the Russians had already done it and have flown those engines. So that's when they started importing those engines, and that's why the RD-180, the NK-33, all those engines come in. So if you think about it, technology-wise, the United States was still behind Russia. And one of the documentaries, the engineer says that was a hard pill for a lot of people in the rocket industry to swallow in the United States. That the technology in Russia was like miles ahead of the United States. So I don't know, if you say the US is like technologically more advanced, I would still think about it a little bit. Yeah. They were extremely advanced in controls, but yeah.
They've put the first human in orbit. I would only attribute why Russia couldn't be is not where the US is right now is because of just the political turmoil. It's absolutely not about the technological prowess. Because even if we read, what's this book about Yuri Gagarin? There's this amazing book that outlines like the whole history of Yuri Gagarin. Yuri Gagarin book. Not Soviet Man. Starman, yes. Starman is the name of the book. I don't know if you've read Starman.
I have not, but I will try to get a hold of it.
Yeah, it's quite awesome. I don't know, maybe as a propulsion engineer you might enjoy it way more than I have.
There's another book that's actually impending in my list of books to read. It's on Sergei Korolyov's like biography.
Oh wow.
So
What's the name of the book?
I think it's just called Sergei. So the the reason why I said that was because there was a recent conference, and we were discussing like rocket history with one of the Air Force people, and he said a quote that he read in one of the books, which said basically the aerospace industry is basically politics, economics, and engineering in that order.
Hmm. I love that.
I thought that was a great quote that could be inserted at this particular part if you don't have your politics, or if you have both politics and economics right, and you don't have your engineering right, it's the same problem.
The fascinating part of it is that it still holds true and it will hold true for the foreseeable future of humanity. Everywhere, even if you look into science fiction, that's essentially the theme. If you look at The Expanse, that's what it's about. Wow, so cool. That's awesome. I should probably get a t-shirt printed and wear it around.
I wish I could attribute the quote to somebody. I don't remember who it was.
I'm pretty sure we can find it. Let's Google that. And
I couldn't. I actually Googled it.
oh, really?
Let's see.
Anonymous. Maybe let's just attribute it to Anonymous. So you also mentioned that a lot of people are, especially a lot of Indians, are going back to India. So what are these people doing? Because now, of course, there are a bunch of aerospace companies, there are a bunch of rocket companies, which are also quite nicely funded, which is an amazing thing. So, a lot of your friends or the Indians that you've seen, are they working with these companies, or are they working going into the Indian academia, or what's happening there?
So I've seen a few people go into like places like Indian Institute of Science, IIT Madras, IIT Bombay, Kanpur, etc., all where the aerospace school is pretty well known. I've also seen a lot of people work for private engine OEMs like Rolls, GE, etc. But these are just two names, but they have big factories in Bangalore and they're going there. Then an extremely small fraction, like you could count the numbers out, are going to go work for like private space companies like Agnikul and Skyroot. Again, I think these people are all seeked out by the private industry for their expertise so that they can actually improve their human capital skill set. So that's why they're like actually sought after probably by these private companies. But if people were going back to India, they would also expect a certain level of pay, which sometimes the private companies might have a difficulty paying. So that's probably why the numbers are dwindling as you go into startup based companies as opposed to established private players. I'm not sure if a lot of people have actually joined up like organizations like ISRO, because when I spoke to a lot of people, they were saying that in ISRO there is still an exam, and there is still like even after you finish your PhD, there's like a long interview process, and you still start off not too high in the ranks, I believe. So I don't know. I think one or two people said it was not worth the amount of effort they had to go through, but it is what it is. So there's no lateral entry into the organization structure that they have.
The lack of a lateral entry into the hierarchy, and also not being able to get into a larger decision making role, I think this is the much bigger deterrent than an exam or an interview, right? If you're an aerospace engineer, you can totally ace any exam or any interview. I guess PhDs can only enter at SD or something level. So essentially that's the level where if you start out as an undergrad at ISRO, you reach that level like in 3 or 4 years. So that's about it. So 3 years or 4 years of your time at ISRO is equal to a PhD, which I wouldn't say is quite equivalent, right? Because American PhDs or aerospace PhDs are quite rigorous and quite longer than 4 years.
So at least in the US, in NASA, for example, instead of just starting off at SD, you could start between SD and S, like, I don't know, EF. I'm not sure how many levels are there. In NASA, it's, I think, GS scale, the pay grade scale. And then they basically have a band. They'd be like, you can be between 9 and like 12 or something if you have a master's. What people, when they join the organization, they negotiate with the manager, and the manager actually promises in about a year or two, once you have the certain level of experience, that they can meet to reach the lowest requirement for the next grade scale, like the grade band. Then in a year or two, they'll actually promote you to that band rather than going from 9 to 10 to 11 to 12. You can start off at 9 or 10, take a pay cut for a year and a half or two, but then immediately jump to GS 12 or something. So you can do those like jumps, and then that's all at the discretion of the manager. And the reason why they do that is in the US, a lot of poaching happens from the private industry. Of the government employees by the private industry. Let's say you're a NASA employee and you're sitting at a certain desk today. Tomorrow, you could be hired by a private contractor that'll put you at the same desk. You would not even move desks. You'd just be at the same desk, but then you'll not be a NASA employee anymore. You'd be a private contractor employee. And so you get a lot more money if you're a private contractor employee. So people try to like move away from the government organization as they progress, and like they're reaching the limit of their career. So that's one part. And then they're also like, a lot of the private companies do try to like poach experienced engineers in the government sector so that they can get skills and resources that they don't have to contract and pay NASA through NASA, because you're still paying a large money through NASA. And in order to prevent all of these, then the upper level management has the ability to like do a lot of lateral entry and provide a lot of positions and promotions, etc., so that they can retain their capital. Because if a propulsion center doesn't have good propulsion engineers, they only have five, you can't function. Five people cannot do all the jobs. So in order to keep all the jobs full, it's the role of the managers to actually convince the people that being in a government actually ensures job security and a whole bunch of other advantages, which you don't have in the other private industry.
Wow, that's quite interesting. Hierarchy-wise, ISRO is still quite rigid. Has been quite rigid, but it might change because there's a new chairman now who's been appointed very recently, and he's a very young person and quite known in the amongst the ISRO crowd to be a visionary and very dynamic and open to change. So yeah, let's see how that pans out. Speaking of Indian universities, right? So now space has is getting more and more popular in India. A lot of universities also sometimes approach me on kickstarting an aerospace research lab or some sort of space activity. If they want to build satellites, it's quite easy because you can just wire up a bunch of sensors to a, I don't know, like a Raspberry or not, and just put it on a balloon and fly it. And there you have a high altitude platform, essentially a satellite. But can something like this be done with low effort and low money for aerospace research?
So the answer to that is yes for the materials, but it's probably a no for the skill set. Because if you so for a propulsion lab, right, you could set up a lab maybe in about $50,000 to $60,000, a small propulsion lab that does maybe gaseous oxygen and methane or something like that, like very simple small scale engine that's like about 2,000 to 3,000 pounds of thrust. So you could try to build it in a short dollar amount. But the problem is not just the materials, right? The problem is a person being able to handle these systems. Most of the time, that expertise is stuck in India in an extremely secure job, either in Godrej Aerospace or in ISAR. Because you don't want to leave your job and do something completely arcane because you don't know if that is going to be supported in the days to come. So that's why it's a little bit of a challenge to move these people out of the organization. The other thing is that I've heard that there is a bunch of liability issues that come along if they try to employ Godrej Aerospace or ISR engineers, like not employ, as in they try to use their help to actually build a rocket in in a university setting. Something bad happens, then who's going to take the liability for it? Is it the university? Is it the ISRO person? Because the ISRO person could say that I was not there all the time, but the university could say that, hey, he didn't teach me. So there is a big liability issue also. So I think the best way to solve this is if a university, somebody like IIT Madras or ISC Bangalore, which has a lot of capital to hire these high level engineers, offers them a government job and hires them in just to develop this particular capability, then that makes a lot more sense. And not only develop the capability, but also start providing funds to use the capability. By what I mean by that is when they're developing their engines, they should use this tinier resource, like small scale engine test facility that was developed for that purpose. The ISRO should fund these education institutions to analyze small scale engines at those facilities instead of doing it back in their own Mahendragiri facility, for example. So that's how you like slowly diversify all your bets and keep the universities producing good quality engineers so you can benefit from it in the days to come. Because at the end of the day, the government's money is the people's money. So you're investing in people and you're investing in capital so that you get a good bunch of engineers who can then go find jobs in the industry. To recap your question, yes, you can build a small scale rocket facility. You just need the expertise to like build that.
First of all, 50, you said 60,000. That's about less than 50 lakhs, essentially, right? In Indian currency. Wow, that's peanuts. And second of all, maybe there could be a startup idea here, right? Somebody like you, for example, can set up, I don't know, like a small consultancy or a company, get together with three or four other people and manage these labs for the universities. Would that work?
That's possible. It's just there is no proven market, or at least I haven't reached out. My long term plan is to go back to India, but I hadn't reached out necessarily to these universities to see whether there is actually a merit to building these labs, and they actually funding this on a continuing basis, because at the end of the day you need money, right? If you employ 4 people who have all this expertise, you're not able to pay them, then nobody's going to stick around. So that is probably a startup idea to do that, but then somebody needs a proven track record, as well as somebody needs to foot the bill.
Does the expert need to be at the university, be employed by the university full time? Can't they just show the ropes, I don't know, for 6 months, give some training to the existing professors or lecturers?
I'm not saying it's not possible. I'm just looking at the way my lab functions, right? So Scott Meyer has been in the lab for about 20 years, 20 plus years. And even today, a lot of us feel that if he leaves the lab to go to the private industry, that's a huge loss for the lab, because he still brings a certain insane level of expertise into the university setting, which would be lost if he decides to go work for the private industry, or if he decides to do this at a part-time consulting, because you cannot do justice to that job. So in a way, I think it is imperative that the universities invest in this human capital rather than use them only on an on-off contract basis. So Scott Meyer, who was the managing director of the lab, was actually, before he became the managing director of Zucro, when he graduated from Purdue, he actually got his master's from Purdue in 1993, I believe. He actually went to work for a wind tunnel facility, AEDC, and then he went on to work on a private space company called Beale Aerospace. That is the company that was the United States, one of the first all-up launch vehicle startup company. So very, very similar to the SpaceX model, where they were doing pressure-fed peroxide RP engine. And Scott was one of the lead people that actually, designed, built the engines. And Beale Aerospace was lived for about 3 years. They built their McGregor engine test facility down in Dallas, in Texas. 3 years later, Andy Beale, the owner of the company of Beale Aerospace, tried getting like funding from NASA, and NASA was very, against private companies doing the entire launch vehicle. And so Andy Beale actually wrote a letter. It was like it's still there. You can find it online. Andy Beale writes a letter saying that we will not be able to have a private space industry until NASA changes its mindset. He folds his company in 2001. Then so Scott comes with all that expertise, moves into Zucro, and then starts building a rocket facility and actually takes it up like really to the next level, to a point where I think Purdue, without blowing our own trumpet, to say that it's one of the propulsion labs that like has facilities that is not matched or paralleled by almost any university in the world. It's probably very close to DLR, but DLR is a private organization. It's not a university setting. So this particular propulsion lab was actually taken up to that level by a person like Scott. So Scott was invested in by Purdue as an engineer, and then he went on to become a senior engineer, then became an assistant director or something like that, and then he finally became the managing director of Zucro, and he's been in that position for about a decade now. The reason why I said this was because that's a great human capital that you want to have. And so if Scott was here on a contract basis, I don't think Zucro would ever be in the position that it is today.
Yeah, I absolutely get that. And DLR is actually a publicly funded research institute. But yeah, I absolutely get that. I'm just looking up Beale Aerospace. Andrew Beale is a banker. Wow, that's so cool.
Yeah, he's an investment banker. And a lot of people think, oh, wow, Elon built the McGregor facility. That's not true. Scott and his crew, at least as far as I know, and his crew and from Beale Aerospace was the one that built the entire engine test facility in McGregor. It was funny, in the history of things, about that time, in about a year or so, NASA's mindset changes and they're like, okay, we'll just start funding private industry. And Andy Beale basically was, I don't know if he was annoyed or what, I can't speak for him, but you can see that I think in one of the letters, Andy actually writes, Elon's a smart guy and he actually he bought my McGregor facility, but Elon bought the McGregor facility for peanuts. I mean, for cents of the dollar.
Wow.
It's basically, he got that entire test facility that was built by Andy Beale, who I think invested about $1 billion. I don't want to be wrong about the number.
Why doesn't anyone talk about this?
That's because there's a lot of SpaceX fanboys too. So
There's also this another company, right? Bigelow Aerospace. I think that also started around the same time, around 2000. Have you heard about that one?
probably the name rings a bell. I'm not too sure what they did. Oh yeah, Bigelow. Okay. These are the people that like built the the expandable modules. Okay, that's why the name rings a bell. But in any event, yeah, I think Beale Aerospace it deserves a good bunch of recognition, which is lost in the noise that private companies create these days. So much noise, in fact.
Yeah, yeah. Lots of space tourism and trying to make, I don't know, trying to draw a lot of attention to space.
Yeah.
I find it a little funny because space is already sexy. It's always been super awesome.
Well, that's what Elon did. He made space sexy, which was the biggest, I think, takeaway and credit, because you could have a whole podcast on that.
Got to give it Elon Musk, right? Because one tweet by Elon Musk can essentially topple the whole financial markets across the world. So that's a lot of power, and that's fascinating. One question for me that I always have is, you're from India, I'm from India. Both of us are from India. We know a lot of Indians who are working in the space sector. So, how important do you think is getting into the IITs and the NITs? Because when I see a lot of Indians who are working in the space sector across the world, a lot of them are not from these elite institutes. They are from a lot of non-elite institutes, right? They're from across the spectrum because we clearly have a hierarchy in India, at least when it comes to engineering colleges or universities. And they not all of them are from the IITs. A good chunk is from these other institutes. So I want to basically have your perspective. How many people, how many really amazing aerospace engineers or engineers in general you have worked with have not come from these institutes, from this whole IIT and IT ecosystem? And what makes someone a good rocket scientist?
Yeah. Okay. So I guess let's start the first question. So I, it's funny. I've not ever asked anybody who's working at Zucro or any one of these places which university you went to. Partially, it's because I went to an extremely tiny college. At least it was tiny at the time when I studied. It was called Rajalakshmi Engineering College. Nobody knows about it. They have an extremely tiny aerospace program. And most of the stuff we did was just math and books. And that's why when I joined Zucro, I didn't know what a wrench was. I hadn't even tightened down a bolt in my entire life. So at that point, it's not that bad, but it's having very little hands-on experience. But the opportunity that I got was I had a chance to work with Satya Chakravarti's group, who's now co-founder of Agnico. I got a chance to work with his PhD students at IIT Madras, helping them with their combustion experiments. It was extremely tiny for me, but I was extremely happy to do it because I was young and I had a lot of time on my hand. So I was happy to help out with their combustion experiments. So you don't have to be a part of an elite institute in order to get access to the institute or get access to the resources available in that institute. I kept cold emailing Satya. I still have those emails. I still carry around his card, which like I kept cold emailing him saying, "Hey, I'm interested in combustion stability," because okay, but there is a certain level of privilege involved here because I had access to YouTube and a bunch of things, but I saw the F1 rocket engines, like their combustion stability work, and then I Google searched it. So every single thing that I'm telling now is a sign of privilege, which I did have. But yeah, I Google searched it and I found that there is a person who's trying to do combustion stability work in Chennai. That was Satya and Sujit. There were two people, two Professor Satya and Professor Sujit. And so I kept cold emailing them, and then Satya replied back to me saying, "Hey, you can come and help out our PhD students if you want to." There was nothing official. It was more like an internship. I was not paid for, but it was just me hanging out with them. So I hang out with them. I help them with their experiments. I remember putting my first ever all-nighter, helping them out with an experiment like a turbulent methane flame. But at that time, it was a huge deal for me because I was an undergrad and I didn't have any of this opportunity. In a way, if you are able to deal with the books and work through the equations by spending enough time on it, and you put some effort into getting access into these institutions, because of the fact that they're public institutions, they're set up that way. Every single student who's not a part of that institute also has access to that institute. So that's how I got a little bit of experience there. And that's what helped me get into Purdue University, which a lot of students who were at IIT Madras Aerospace program couldn't get into even. If you think about it, there's some sort of a mystery here, right? Like a person who's at IIT Madras, you would expect them to like easily get into Purdue, but that's not necessarily true. It's all passion driven and it's all how much time and effort you want to put into the work you're doing. And so that answers the question, do you have to be from an elite institute? The answer is no. And in fact, clearly no.
What's the process to follow to get access to the facilities or to work on a project that's happening at the university?
You can volunteer. Volunteering help because of the fact that you're not paying. You might get a relatively lower quality volunteer in like output, but at the same time, if the volunteer is performing quite well, then the professors are inclined to either recommend them for masters or PhD, or recommend them to start earning some level of cash that you can pay. The only way you can do that is by cold emailing these professors and trying to say, this is what I'm interested in. Do you have something that I can do during these hours of the day or these hours of the week? Or do you have some work that your graduate student is overloaded, which 95% of the graduate students are? Uh, like, can I offload some of the work that they're doing? So those two things, those two emails should be able to help you get some job that you can contribute to. And you might not have a lot of skills, but even if you're able to make the person feel that you're offloading some of their work, then he or she is inclined to now help you achieve what you want, and or give you more details and resources and projects to work on. So that's if you have access to an institute close by. If you don't, then that's a whole different ballgame. I'm not necessarily sure how we can help out, but given this day and age, information is out there. It's just somebody who needs to guide you so that you can weed through the noise and get the information you care about. Because just having contacts and like just using good level of judgment, like if I'm reading a paper, there are like 500 journals available online, but I would only read it from like a certain quality journal. You see, set up those thresholds. Somebody can guide you to what those thresholds are. You can do that by interacting with the professors. And so with that in mind, you should be able to start only reading good quality papers, and that can help you get experience in these fields.
And this is possible at all the universities that have a.
Yeah, like I said, it's you can email the professors and like try to get some level of experience in these systems. It's that people should recognize that IITs, IISCs are all publicly funded. At the end of the day, when your parents are paying the taxes, you are the one that's actually funding these universities. So in a way, even if you don't get into the university because they have a maniacal process to get into them, you should still be able to make use of those resources if you're willing to work for free or for like cheap, which are both acceptable, as long as the professor is okay with it.
This is so amazing. I'm really surprised how more people are not doing it. I guess nobody really knows about this route. I'll try my best in spreading the word. This is gold information.
If there are professors listening here, I'm not responsible for your inbox being full.
That's a good disclaimer. Very smart.
I take no responsibility for this.
Me too. I also absolve of any responsibilities at your own risk. So, the second part of my question, what makes someone a good rocket scientist or a propulsion engineer, or however you wish to answer?
I guess that's very prophetic.
Yeah, an hour of talking hard engineering. I guess we have the liberty now to go into the prophecy zone, not prophecy, prophetic zone.
Yeah, I think a good rocket scientist needs to be able to solve problems. Needs to be able to have that I can solve any problem that's thrown at my face, or should be able to have the knowledge to recognize you can't solve it. So being able to say you can solve it, or being able to from the get-go say it's probably impossible to solve, I think that makes you a good scientist because you're investing your time appropriately. I guess it was not a short and sweet answer, but in many words, that's what I think makes you a good scientist or a research engineer.
This actually reminds me of this nice quote. I don't know, it's part of the serenity prayer. Grant me the serenity to accept the things I cannot change, courage to change the things I can, and wisdom to know the difference. So, same life mantra.
I guess many words is what I did. So that's a succinct way of saying it.
Yeah, that's good. I guess this is what makes a good engineer or a scientist in any field, I assume. So thank you, Venkat. It's been super fun discussion. I would love to have another session with you. But you've shared a lot of incredible insights, which we don't really find anywhere. A lot of tips, for example, about cold calling all the professors or the way you approach things. It's really interesting. I'm sure a lot of people from India or from any part of the world would find it very interesting. Thanks a lot for your time.
Thank you. This is fun.
If student enthusiasts or space professionals want to reach you, what's the best way?
So yeah, my email address, I think, which should be, I can spell it out now. It's vathmana@purdue.edu. So that's my first initial and then part of my last name. And or you can find me on LinkedIn, and I'm pretty responsive on LinkedIn too. So both those resources should be perfectly okay.
Thank you again for your time.
Thank you. This was fun.